Hello and welcome to Controllers Tech. A lot of you guys requested me to do this, so here I am today, with another video on the Riverdi display. Today we will see how to use the button on the display to control the LED attached to the MCU. This seems like a very easy topic, but if you have a Riverdi display, you know how challenging it is. The method I am going to use isn't going to be an easy one, but it will be a universal method for a lot of things. You can use the same method to display the data from UART, any sensor, pretty much anything I have covered so far in the Touch GFX. I am using the latest version of the Touch GFX, that is 4.21.4, but Riverdi has mentioned that they only support the version 4.20. I have already tested this version, and it works fine. Although you won't see the BSP folder generated, like it used to generate on the version 20. I am not going to use any BSP replated files, so this is fine with me. Here I am creating a new project with the Riverdi display. First of all, I am adding a background image to this project. I already have a 1280 by 800 ping image for the background. Let's add a text area to display the LED status. I don't want the auto size. Choose the alignment, the typography, etc. Now go to Text, Typography, and add the wildcard range to this typography. We will use the wildcard for the text area, and the buffer size will be 10 bytes. The default status for the LED is set to off. Now let's add the buttons to turn the LED on and off. I am using the flex button, so that I can resize it as per my need. I will modify this button to look a little more attractive, so under the visual element, click Add, and select Icon. Now in the Icon option, we will add some button icon to our button. I am using this clay theme as it has some good circular icons. The image size should be less than the button size. Choose the images for the button released, and button pressed. Now remove the button with border element, so that the background is removed. Let me adjust the button size, so that the image fits a little more perfectly. Alright, let's name this button as the on button. We need to create one more button, the off button, so we will just copy this button, and change some things. Now the buttons have been created, so we will also define the interactions. When the on button is clicked, it will call a new virtual function, the on clicked. Similarly, when the off button is clicked, the off clicked function will be called. That is it for the designing. Let's generate the project now. Open the project in the Cube IDE. Here is the project structure. Let's take a look at the GPIO.c file. Here some pins are already configured for certain purposes, so when you choose a certain pin to be an input or output pin, make sure not to choose from these. I need one pin to be configured as output, where I can connect the LED to. Let's quickly see the datasheet to see the availability of the pins. I have this particular display from Riverdi. Here is the link to download the datasheet. Alright, as you already know, we have the expansion connector on the display, which can be used to connect GPIO, I2C, SPI, etc. I will use one of the pins from this connector to be used as the output pin. I am going to use this PA5, but this is already being used as the DAC pin. So we need to first disable the initialization of this pin as the DAC pin, and then initialize it as the output pin. Here in the DAC source file, you can see the pin PA5 is being used as the DAC output pin. So go to the main file, and comment out the DAC initialization function. Now we will initialize the pin in the output mode. If you know the initialization code, write it, or you can refer to the gpio.c file. Here this pin is being initialized in the output push-pull mode, so I will copy this part. Let's write a function LED in it. We also need the definition of initialization structure. Also reset the pin before initializing it. Now change the GPIO port to GPIO-A, and the pin to pin 5. Make sure the clock for the respective port is enabled, if not, then enable yourself. Now in the main function, call the LED init function to initialize the LED pin as output. Let's build the code once. We have few warnings, but that's alright. As I mentioned in the beginning, I will use a harder, but more common method to control this LED. I am going to create a new task to blink the LED, and queue to transfer the data from GUI to the MCU. A much better way of approaching this is to create a new source file to write our code. This way we will have our code separated from the predefined one, and whenever needed, we will only make changes in that particular file. So I am creating a new source file, myfile.c, and a new header file, myfile.h. Now we need to move these files to the main project folder, where the rest of the files are stored. Open the newly created file in the System Explorer. Now we will move these files to a different location. Go to the main project folder, CM7, Core, Source. Move the .c file here, and .h file in the Include folder. Now both the files have been removed from the IDE. So we will link the source file to the core directory. Make sure you link relative to the project location. Now we have the file here, and we can write it. We will start with certain inclusions. So here I have included the main header file, my file header, cmsysOS for the RTOS. Task header file for the task-related functions, and queue header file for the queue-related functions. Next we will create a task and a queue. We need to first create the attributes for the task and the queue. If you don't know the functions for the same, you can refer to the free rtos.c file. Let's copy the attributes of the default task. Now we will change the word default with the LED. So we have the LED task handle, and the LED task attributes. Now create the attributes for the queue. Let's define the LED queue handle. The queue attributes just require the name parameter. Next we need to create the task and the queue. Let's write a separate function to create the LED task. The start LED task function will be defined later. Alright, let's create the queue now. The size of the queue should be one element, and the element size is the size of the integer. Basically this is going to be an integer queue with one element. This is because we only need to transfer with a 1, or a 0. Now we will write the start LED task. Again I am taking the reference from the start default task. I have covered this part in detail in the previous TouchGFX videos. We will first check if there is some message in the queue. If there is, we will copy the message into the variable LED state. Let's define the integral variable LED state. Now the LED state will be set as per the value of the LED state variable. This task will run every 10 milliseconds, but the LED will only set when there is some data in the queue, that is, when the button is pressed. Define the start LED task at the beginning. So we create the task attributes, and the queue attributes. Then we create the task and the queue. And in the end we write the task function. We need to define these initialization functions in the myFile header file. Now go to the main file. Include the myFile header. And initialize the task and the queue, after the FreeRTOS initialization function. Now we will write the code for the GUI. Open the GUI folder, and we will start with the Screen 1 view source file. We have defined the interactions when the buttons are clicked, so we first need to define these functions in the view header file. Now when the on button is pressed, the onClicked function will be called, and here we will call the LED control function in the presenter, and pass the parameter true. We also need to display the LED status in the text area, so first use the string copy function to copy the LED on string to the text area buffer, and then invalidate the text area. Similarly, when the off-clicked function is called, we will pass the false parameter to the LED control function, and update the text area with the string LED off. Now we need to define the LED control function in the presenter. Here we will call the same function in the model, and also pass the state as the parameter. We also need to define this function in the presenter header file. Finally, we will write the main code in the model file. First include the CMSysOS header file, so that we can write the queue functions. Include the myFile header also. Now define the LED queue handle as the external variable. In the LED control function, first check if there is some space available in the queue. If it is, then put the message in the queue. The message is the state variable that is being passed from the view file. Let's build the code now. We have to define this in the model header file also. Alright, the code builds fine. But it will show an error when you flash it via the TouchGFX, so let's fix that too. Open the project folder, and go to the root folder. Here go inside the GCC folder, and edit the makefile for CM7. Scroll down till you see the board C files section. We need to add one more file for the compilation. So add the myfile.c here. Save the makefile, and open the TouchGFX again. Let's see the simulator first. The project is running fine on the TouchGFX, so let's flash it to the board. Target has been flashed successfully. Here you can see in logs, my file.c was also compiled, and therefore there was no error. Let's see the project working on the board. You can see the LED is responding well, and the text area is showing the status. So everything is working well. I will continue with the Riverdi display, and make more videos covering the UART, and some sensor. We will continue with this file we created today, and add more functions to it. This is it for the video. I hope this video sheds some light on how to work with Riverdi display. The link to download the code is in the description below. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.